Hello developers, let's start developing. I am Veko and today we're gonna take on the 13th day of the 2024 Advent of Code. So it means we are exactly at the halfway point. So half of the tasks are behind us and that was the way easier half, and half of the tasks are in front of us and those are gonna be kinda harder. However, let's focus on this one. When I started reading this task, the first thing I said, the hexagonal floor tiles, and I said, oh no, we're gonna have to do something with hexagonal mathematics and index management and whatnot, so we're gonna have a hexagonal matrix. Fortunately, that's not the case. We have a claw machine that we need to win. So basically the claw machine has two buttons, A and B. One pushes the claw, both push the claw in kinda forward right direction, but they push it in a different amount. That's the button A, that's the button B. The button A costs 3 tokens to push, the button B costs 1 token to push, and we need to find if we can get the price and how much it will cost. Well, first of all, the input is kind of weirdly shaped, so we're gonna need to parse it using regex. So let's get on to that. So we're gonna need to read all the lines, and now you can see that the lines are kind of grouped in pairs of 3. So we're just gonna need to say while I will do something like a loop and a half, so we will have line is lines dot shift while the line is not empty. We're gonna do something while the line is, I'm gonna abuse truth here, so the lines is gonna be either if it's empty or if it's undefined, we're gonna break. So now we're gonna have to take, so actually we'll call this first line. So we're gonna take the second line, that's once more the third line, and we're gonna shift once more just for good measure, because that should be the empty line after that. So we're taking 1, 2, 3 lines, we're remembering them, and we're going on. So let's see what we need to do to actually get the data. As I've said multiple times, you never want to write a regex inside your code, you always paste it. So this is the value that we want to match, and we kind of want to get put on. Yeah, let's take the whole input. Yeah, even this one. That's identical. So we need to match. So we have a start of the string, then button, then we have A or B. We kind of don't need that, so we can turn it into a non-matching group, because we know whether we are matching A or B, the first line or the second line, then a space, then an X plus, and then we have what we actually need, because that is a few digits. Oh, it says it doesn't match. Why not? It matches up to here. Oh, and then we have the plus. We don't have a plus in the regex sense, we have a plus in the literal sense. So then we have a few digits that we want to take care of. So we're extracting 54 and 36, and then we have a comma and a space and a y and another literal plus, and then we have a few more digits that we want to take on. So we have the x and the y's, and we can, and then the string ends. Yeah. So let's start on that. I will write this out as constants. So the button regex is this thing, and we're gonna need to match this using the button regex. That's the first line match. And this is an arrayx match array, so we can take of 1, I think, and f match of 2. And I will definitely log this to the console to see if we have, yeah, we know this is not null. We can actually say if it's null, throw something, but let's see if it is. Run the 13th. It's a bit of warming up in the morning. Oh. And we run into an endless loop. Well, we're getting 94, 34, 94, 34. Yeah, we might have wanted to do a bit of a check here, but let's see, 94, 34. Yeah, those are the values kind. So let's continue with our code. We have the values, so now we just need to parse them. And what will be the type of our input? Well, we will have something like claw machine. It will have the A moves that much to the X and that much to the Y. Well, we might need, no, let's have it like this. We don't, it's not a point specifically, and the price will also be at a given location. So we have three, not points, but kind of locations. So our result will be a claw machine array. Initially, it's an empty array. This is the empty line, and at the end we need to actually take the first line again, and that is the line that we're matching. So we have the first these matches. Of course, we're gonna need the S matches, and we're gonna need the third matches, but we're not gonna match on the button regex. We need to match on something a bit different. So let's get that. So we need to match on price is x equals some numbers, then a comma, then a space, then y equals some other numbers. And the string ends. So that's the price regex. So this will be matching on the price regex, and all of them have two different matches, so the claw should be, now we're gonna have the A, the B, and the price, and those are exactly what we want them to be, the first and the second, the first and the second, the first and the second, and of course we're gonna need to push our claw to the result. And the input is not gonna be a string array, of course. it's gonna be a claw machine array. Seems like we're doing something. We're not returning that, we're returning the result. So first of all, let's write out the result, the input. And see whether we get 4 claw machines with the required data or we get something weird, in which case we will need to actually debug. So the third match didn't go through. I made a boo-boo. So it says the third match is wrong because we're not matching the specific lines. Always, and I mean always, check the code. Any code generator generates for you, because in this case it made an error. And this is again why it's important to check whether the input that we're working on is actually the input that was given. So we have 9434, and that's is what we needed. 2267, 2267, 8400, 5400. Seems that we are correct, and all of these are actual numbers, which means it's quite okay. So now we need to continue with the task, specific task, and I feel that's gonna be the easy part. I'm gonna move a bit to Excel. So let's take a look at the first task. So we have 94. The first, let's rewrite. Right. A moves it on the X 94 and on the Y 34. On the B button moves it 22 times on this and 67 on the Y scale. And our targets are 8400 and 5400. So that means that if we press the button A times and the button B times, the X coordinate will be 94 times, actually, let's use a reference, this many times A, this many times A, plus, yeah, I want a literal plus, this many times B, and that is gonna be equal, that should be equal to this many X's. Let's do the same thing for the Y. So this many A's plus this many B's is gonna equal, should equal this many. So I'll just copy over these so I don't need to do all the single quotes. So what is this? This is actually a system of linear equations that we all learned in somewhere around middle school. So we kind of need to solve this, and we can actually solve this. So we can transform this. So this will be these two numbers multiplied together. Of course, we can take out the GCD and divide this with the GCD, but these are relatively small numbers and the computers don't really mind multiplying bigger numbers as well. So we're gonna take everything we have here and multiply it by the other coefficient before A. So this will also be this much multiplied by this same thing. So basically we're multiplying everything in this line with 34 and everything on this line with 94. So, and this will also be this multiplied by this much. And we're doing the same thing for these numbers. So this will be this multiplied by this much. And this thing, oh, not negative, equals this thing multiplied by this much. Okay, now we have the same two equations, only they're multiplied by a certain something that ensures that these two numbers are okay. So now, if we subtract one from the other, we subtract this from this, we get 0a's plus. Actually, I'm going to subtract them the other way around. It doesn't really matter. Yeah, I can subtract this minus this. That should equal this minus this. This minus this. So these 0a's plus that many b's equals this many. So now we have a simple thing to do. How much is b is actually this thing divided by this thing, which means we need to press the b button 40 times. How do we get how much a is? Well, that's simple. We can take whichever of these we want, but if from this value, we subtract this value times the value of b, we get how many 94's a's are. So the only thing that we need to do is basically divide this with 94, and we get that the solution of our system of equations is that a has to be 80 and b has to be 40. And let's see, that's exactly the solution that we get here. The A button for 80 times and the B button 40 times. Let's move on to the second example. And this is why I always did it with formulas, so that I can just do this. So this is 26, this is 66, this is 67, this is 21. And we're getting weird numbers, which means that this is not a possible thing. We cannot press the A button 106.8 times. We're looking for integer solutions. So the system will either have integer solutions or not. If it doesn't have integer solutions, we don't have a solution. Or maybe if one of the solutions is negative, we cannot press the B button -3 times. Let's see this third one. 86, 84, 37. Oh, just a sec, I made an error on the first one. These are not all the numbers 21. We need this to be 12748. Oh, we might get a solution. 12176. No, we didn't. Okay. 17, 86. I'm putting in the third one. 84, 37, 7870, and 6450. Oh, here are our solutions. 86, 38, 86, 38, we are correct. And the fourth one is 69, 23, 27, 71. Here we have 18641, 10279. We're getting some weird numbers. It's wrong. Additionally, we have an additional condition that says you estimate that each button would need to be pressed no more than 100 times. So I guess this is a hint that if you get a number that's higher than 100, you just kinda ignore it. So one way to solve this thing would be just to use Excel. We can use it, but I already decided on this thing, TypeScript, so we're gonna do that. So what do we need to do? So first of all, we need to find what we actually need to compute. We need to compute fewest tokens you have to spend to win all possible prizes. So we need to get a number of the whole prizes. So we have that let tokens. Initially it's 0, and we're just gonna loop through our claw machines. For each claw machine of the input, we're gonna need to kind of solve this. Oh, that's totally wrong. So we're gonna need to rewrite everything we did in Excel to actually do that. So how do we did it? Let's work our way backwards. So this thing is that thing minus that thing. So we're gonna work our way backwards, and then we're just gonna replace everything until we get that all of the references here are basically one of the numbers above. So in this case, since this actually equals to B1, I can just change it. So this is B1, and this is this number, and this is this number. So for A, only the B14 needs to be changed. And I will revert to the first example because that gave me nice numbers, so I know that if I mess something up, I won't be getting nice numbers. 22, 67, 840, 8400, 5400. Yeah, we got 40 and 8. So let's see. We have G12. So instead of G12, we're just gonna say this. Adding parentheses as needed. Divided by D12, it became 1. Oh, we changed the wrong thing. That's D12. And of course, G12 was actually this. Yep. So now everything is connected to that thing, but let's see what this is. This is D6 times A7. And yeah, let's do that. That is D9. And this thing is D7 times A6. Oh, I messed it up, but we know that it is the other way around. So now we can just move them a bit. So it's this is 34, this is 22, this is 67. So we have that this thing actually connects, the bottom half connects only to the input. So we still get 40. Now, let's take this thing. This is G6 times A7. And of course, this is G7 times A6. Great. So let's move them once more. This is here, this is here, this is here, and this is here. And now we have much better things. I will leave B14 here because that is a value that we will get. So that means that the B value can be calculated using this only from the input. So I will actually paste this thing into my TypeScript code. It's this, and now we will need to replace this with their proper names. We can literally deconstruct the claw machine here into an A and a B and a price. So let's see what's B4. B4 is price.x. Yeah, let's add another row here. And this is y. So now they're gonna be off by 1. So B4 is price.x multiplied by C1, which is A.y. And from that we subtract, actually let's change it in all the places. Yeah, C1 is A.y. And then we have the first and the B column, that's A.x. We have C4, which is of course price.y, and we have B2 and C2, these two, which are B.x and B.y. Yeah, this is not some secret formula that I'm using here. What's the problem? Oh, this is B solution. This is not a secret formula that I'm using here. It's actually a formula that sometimes it's even given as a solution to a set of equations. And of course, we can even calculate A using the same thing. We just need to replace all the A's with B's and all the B's with A's. But we can just rewrite it in that way that it's B, yeah, it's B5, which is the price.x, I think it got it right, minus B.x times the B solution divided by A.x. Note that this only works with the x's. We can do the exact same calculation using the y's and we would get the exact same solution. So now we have our A solution and B solution, so I will just console log them to see if we're on our right path. So basically we didn't do a lot of programming except for the regexes. Most of this was actually math. So we're getting what we're supposed to get. I will add a check. For example, if math.floor of A solution and math.floor of B solution is equal to that. No, we're gonna go the other way around. So if that is not a whole number or that is not a whole number, move along, nothing to see here. So otherwise, yeah, let's just log the solution. So we should get only the first and the third one. Okay. So now we know that they are even numbers. If one of them is less than 0, again we continue. If one of them is bigger than 100, what does it say? Let's see. Each button would need to be pressed no more than 100 times to win a prize. So each button is, so we're gonna say if it's bigger than 100 or B solution is bigger than 100, there we're just gonna continue. I have this to have a separate cases because we might need to put some debugging here because some condition failed. If this doesn't work, otherwise, so we can say the token is equal to 3 times, that's not the correct number, 3 times the A solution plus the B solution. And then we just return the number of tokens. This turned out to be programmatically quite a simple thing. But let's see if the answer we get is indeed 480. And now let's see what the answer will be for the huge input and whether it's correct. We have a lot of cases, a lot of claw machines, and we're gonna win every single one of them. And we're gonna spend 27,000 things, tokens to get them, and we're gonna get a star for spending that many tokens. Let's see what part 2 is. The claw is nowhere near where you expected it would be. Oh, it's actually that many times higher on both. Yeah, now it becomes more interesting. We need to add something to that. I don't think this will be an issue. I'm not sure but the problem that we're getting into now is actually the number precision problem. So what we need to do is first to say price.x and price.y is increased by the offset, which is not that many, but it's this many. I'm not gonna count the zeros. I will see what this thing says. So we have 3 zeros and 3 zeros and 3 zeros and that. So this is kind of million, billion, thousand, million, billion, trillion. So 10 trillion. And this thing has 3, 6, okay, I'm counting the zeros. 3, 6, 9, 12, 13, 14. So if we get to any position when we need to multiply this with something that's like 100, we might get above the magic number for JavaScript. And as I've explained, the magic number for JavaScript is a constant that I will kind of have to take care of. So we have this thing, which is a bit bigger than 10 trillion, but not by much. Where were we before my phone rang? We were worrying about the max safe integer. So let's analyze our code a bit. Let's see what's happening. So we're gonna need to increase the price on both these things by the offset. And here we have some multiplication when we're multiplying by y. And y is in the order of less than 100. So this number is about, I think, 900 trillion. So we might be okay, we might not be. This is the max safe integer. Oh, it's a bit bigger. So it's about 900 times bigger. We might be safe. I have no idea, but there's one way to find out. Otherwise, the solution is totally independent. You can see that we're not looping through anything. So that doesn't really matter if we're looping or not. Only this condition has to go. And let's go back to the small input and see whether we get that. I will add a console log just in case. Let's see if we have this thing. It will take more than 2 presses. Oh, this is weird because we don't get the correct answer. But let's say solution or negative solution or something like that. So let's start this. Yeah, I hate that we don't get an answer to this example input, only that it's bigger than 100. So processing the first one, non-integer solution, processing the second one, we get a solution, processing the third one, non-integer, the fourth one actually gives us an integer and we get a result. Okay, so let's go back to the huge input and try it. It won't be significantly slower than the first one, so we should also get it in about 0 milliseconds. But we should get much more input printed out, and we got some solutions. Let's see if this number is actually correct. I really hope it is, otherwise the debugging will be relatively manual and boring. Fortunately, that's the right solution because we got lucky. The numbers were relatively close to the max safe integer, but they were not. Otherwise, I most likely would have gone with big int numbers, which are supported in JavaScript, but are much slower and kind of harder to work with. Anyway, we managed to solve the 13th task using some high school or elementary or middle school math, depending on where you went to school. So this was a fun thing to do and kind of deterministic. The code is not really optimized, I would say, but it's analytic, since we're just getting the data and calculating some based on that. That's all we do. So yeah, I will remove the console logs, and that's about it. So if you like the video, like, subscribe, comment, whatever you want to do. Don't touch the bell button and keep developing.